Alright guys, welcome back. So today we're going to be doing a bit more of a practical video, and I'm going to show you how to process raw data from an experiment. How to do it'll involve things like error propagations and so on and so forth. Now, this is a chemistry IA. This is obviously not mine. I found this one on the internet. I literally just Googled chemistry IA exemplars on Google, and this came up on the first page. I've censored obviously all sensitive. I've censored. I have censored all personal information because they do write their name on basically every fucking page, and I also censored some information that we don't need necessarily that I don't want to have. So I censored it up. So if you see these black splotches, those are things I intentionally don't want you to see. I've hid their name, I hid their candidate number, and so on and so forth. So without further ado, let's skip to the processing. I'm not really going to grade this, so here is our raw data. Just so you know, the IA's topic was finding vitamin C in vitamin C content in kimchi. So this is sort of, they did ideometric titration, and this is sort of their results. There was only one reaction involved. There was no real pre-treatment procedure necessary to do. So with that sort of aside, let's go straight into it. So we have 3 trials. So let's go to Excel, and I'm going to show you how you can get Excel to do all the heavy lifting so that you don't have to. So what I'm going to first do is I'm going to set up trial 1 initial, trial 1 final, or better yet, what I'm going to do is delete. Let's sort of make a table here. So day 1, 2, 3, 4, 5, 7. Day, and then trial, and let's call this sort of, okay, now we're not going to do that. So what we're going to do is cut. Oh no, we'll delete even. Delete. There we go. So we're going to do trial 1 initial, trial 1 final, trial 2 initial, trial 2 final, trial 3 initial, trial 3 final. And basically what I'm doing now is just I'm inserting, mic setup, sorry. I'm inserting all the data into a spreadsheet so that I can process it a little bit nicer. So I can process it. So, okay, this cell does not need to be nearly as big. Can you go away? No. What I want is that one does not need to be nearly as big as it was. And these are tighter readings. And normally I would add an uncertainty tab, but they're all the same, so it doesn't really matter. So 7, 19.2, 2.6, 8.8, 9.8, 30.20, 31.70. So there's that. Then the trial 1 final is 38.2, 23.3, 15.8, 13.2, 30. Oh wait. Oh, whoops. Those are for each individual day. So we'll just sort of take it. So we'll do that. So we'll only consider day 1. And so for that one, 38. We'll only consider their first trial of data. 38.2, 38.2, and 41.2, and then 41.2, 44.2. Right? So now what we need to do is we need to obviously we need to process the data, obviously. So the way we can do this with Excel, and what we can do is titer trial 1, titer trial, and let's put its uncertainty trial 2 uncertainty, and then titer 3 with uncertainty. Right? Now, so now what we can do is we can get Excel to do the heavy lifting. Now the way we can do that is we can insert a formula into the formula bar. And we can do, so the way you do that is equal, and you can do what is called an absolute cell reference or a relative cell reference. An absolute cell reference is you use, so for example, let's say I wanted to refer to, so it would always be final minus initial. So actually, you know what? I'm going to do this a little bit differently so I can show you the real power of Excel. What I'll do is, let's do this a little bit differently. Trial 1, 2, 3, initial volume, final volume, uncertainty, volume, uncertainty, and then titer, so let's do that. So initial volume was 34.7. For trial 2 it was 38.2, 41.2, 44.2, 41.2, 38.2. Cut, paste, just paste it, yeah. 0.05, 0.05, and then 0.05, 0.05, and then 0.05. And that's sort of how you would do it for titration. Now, for absolute cell referencing, it will always refer to that cell, no matter what you change it. Now, relative cell reference is, it'll call, say you do relative cell reference here to this cell, and then now for this box, it'll refer to this cell, and for this box, it'll refer to this cell as that cell. It's obviously basically what you need to know with cell reference, with absolute cell referencing, it'll always refer to this cell, but if you refer to relative cell references, it will call this the cell A1 or whatever, and then if you do it for this row, this becomes cell A1. So let me just show you what I mean. So it equals final minus initial, and I want these to be relative cell references so that these become the rows. So let's refer to those there. And then if I do that, if I drag this, if I click here so I get the 4 arrows, and then I click down, it will populate the fields in and do the calculation. Now watch here, it goes D2 minus B2, whereas here it goes D3 minus B3, and then here it goes D4 minus B4. And then the way I got it to do that is I used a relative cell reference, and I called this, this is D2, but for this row, this is D2. it keeps it in the same number but not the same letter. It uses the letter of the row, but it refers to the same number. Is I think the easiest way to do that, and that's how you get it to perform your calculations. So that's the volume delivered, right? Cool. And we can even get it to calculate our uncertainties. Now, we know that for absolute uncertainties, we have to add them together. So let's add our absolute uncertainties plus that one. And again, I'm going to use a relative cell reference so that it can automatically do the calculation for me. And then there you go, it populates in the field. Obviously, these are all the same because we use the same apparatus. All right. Now, let's say we want to process our data. Let's go moles I2. And this is idiometric titration. And we know that moles is equal to N equals C times V. Now, the concentration is obviously just a constant. So, but let me show you what I mean by absolute cell referencing. So, concentration of, I believe it's sodium thiosulfate that they use. Let me just read up again. I'm fairly familiar with how these things work. Or do they just titrate with iodine? Hang on, titration. So, alright, so reading here, it's just an iodine titration, so I2. So, concentration of I2 was given. According to this procedure, the concentration of iodine was 0.00500 molar, right? And now let's say we wanted to figure out, so moles I2 delivered, and then 1, 2, 3, no, trial moles I2 delivered. And so now, because we know that N equals CV, we can program that in. So we know that concentration is a constant, and now we want to use an absolute cell reference. So the way I do that is I put a $sign through before both the letter and the number, whereas a relative cell reference was just you put a $sign before the letter, and then it'll call it relative, and then times, right? And we want to use a relative cell reference here so that it will calculate for each trial. So if I do that here and I put a relative cell reference there, we'll get that. And then if I spit out the calculation, I get my calculation delivered. Note here that it goes F2, and then here we can really see the difference between absolute and relative cell referencing. Here, this is always treated as a constant, but we go F2, cell F3, and then cell F4. And then now if we wanted to find the moles of absorbic acid, we know that from the reaction we have to program in the mole ratio ourselves, but once we program it in, it'll automatically do it for us. And then we know that according to the reaction here, the mole ratio is looks to be 1 to 1. Yeah, it looks to be 1 to 1. So since it's 1 to 1, we can just say it equals that, and we do it as a relative cell reference. And then we can do it like that. And then now, say we wanted the milligram content, the content in milligrams of our absorbic acid. Now we have to multiply by the molar mass, and if I look this up really quickly, molar mass of vitamin C amount of absorbic acid in milligrams. Let me just, it's going to look really weird. And then uncertainty in I'll call that uncertainty. And to get the amount of absorbic, it should say absorbic acid. Now, to convert this into milligrams, we know that we first need to multiply by the molar mass, so we take the number of moles here, and we want that as a relative cell reference, times the molar mass, which is 176.12, and then since we're going to milligrams, we want to multiply that by 1,000, right? And when we do that, we get our content. We get our milligram content here. Seems that there's an awful lot of there appears to be an awful lot of vitamin C in the kimchi, which doesn't sound right. 3,000 milligrams. Which, let me check her. Let me check the report that I pulled this off. Yeah, that's way off. Yeah, they should contain about 16 milligrams, not that many. So let's just calculate in the amount of grams first. Unless I did something wrong here. Oh, no, I see our mistake. We forgot to convert this into... We forgot to do a conversion between milliliters and liters. So, one moment. This should be in moles per liter. So we should take this and divide it by 1,000. And if we redo those calculations, we should get, yeah. And then if we multiply by 1,000, we get that there was 3 milligrams, 2 milligrams, and 2 milligrams of vitamin C in the cabbage, which sounds a lot more accurate. In the sample, I should say. So, and then now to propagate our uncertainties, we know that the uncertainty is we know since we're multiplying numbers, so we're multiplying by the concentration, which we assume has no uncertainty in it, and we're also, since we're multiplying by the concentration's uncertainty, so since we're doing multiplication, we know we have to add relative uncertainties, and the way we do that is we now have to use brackets here to do the order of operations, but we do that divided, so we do the uncertainty divided by the measurement. So, and here again I want to use relative cell referencing to make my life easier, and since we're assuming that there's no uncertainty in the concentration or the actually, you know what, I think the uncertainty in the concentration is given. Yep, and it's given as 1%. So plus 0.01 times the measurement, which we're doing. So basically, the way I'm propagating the error is I'm adding the individual relative uncertainties of each measurement, that each number that we're doing. So we're doing, when we do multiplication, we add the relative uncertainties. So I'm adding the relative uncertainties, and then to get an absolute uncertainty for the milligram contents, I'm just multiplying by the measurement. So, and I've programmed that into Excel, and when I do that, I should get that. So we get 3.08 plus or minus 1.0.11. So now one problem, we want to keep our sig figs. So what I'm going to do is I'm going to keep it to 3 sig figs. I don't know how many we're supposed to keep. I haven't really been keeping track, but we can go to the home page, and you'll see this button here which says decrease decimal. So we'll since our uncertainties are only allowed to 1 decimal place, we're going to round it off to 2. We're going to round it off to 1 decimal place, and there we go. Now, to really complete the process, so that's sort of a guide to how we use Excel to process data, and it should have covered, at least to the extent that it really should cover, measurement, uncertainty propagation, and then experimental data to a degree. And then the last step here is we want to get a graph. We should do data, insert even, recommended chart. We're going to use a bar graph. No, what we're going to do is, so now if we do that, we do insert, let's do recommended chart, we'll get a bar graph. We'll take a bar graph, and then here we want our axes titles. We want our we don't need our data labels. We need error bars, which will we have to hit more options here. So both directions, and we have to hit custom. We have to hit specify value, and then we select our uncertainties there, and then negative. So that's our positive one. That's our negative one, and then we hit OK. Hang on. Here, let's try this again. So delete everything. Delete everything. And for the positive error bar, back, we go here, and then we go here. And then we go. That should give us our error bars. So the way I did that, I went into this plus arrow, hit error bars, hit more options, and then I went to error amount, custom, specify value, and then I picked our uncertainty tab. And then I selected the one for the plus and the minus, and that's how we got the error bars there. Now we just label our axes. Vitamin C content milligrams, and then here trial number, and there we go. And that is all of our data processed. Thank you very much for watching. Don't forget to like and subscribe.